Identify problems where equilibrium is there. Where all equilibrium is there, again you can discuss there, is it stable, unstable. That approach is what finally. So where do all this background will help you in SHM. Because in SHM, we discuss about stable equilibrium only, it will execute SHM. So if you're able to identify the stable, unstable, it'll be very easy for you, convenient. This is one, you can say, the best approach what we should have. Total length of the string is given L from A to C. So let me take some points. So let this be equal to Y. And let me write, this is R. What can be so cos theta or select it tan theta equal to, let me have that distance is what we assumed here, no? So y equal to d cot theta, keep it here, no? Then this distance, let it be as sin theta is equal to d by s. So s equal to d cosecant theta. So what is value of r? R should be equal to L minus s. Because to define the potential, I need position, no? And it's telling this is u equal to 0. If I move down, the things should be negative, no? Because I'm defining this is u equal 0 means this is a position. From here is what I'll measure. So anything if I measure vertically down should be taken as negative. Okay, define now the potential of system. Potential of system should be u is equal to, all the blocks are having same mass m. So block C, UC plus UA plus UB. Since UA equal to UB, no, they are at same height. So therefore this will be UC plus 2UA. Now what is the value of UC? Minus mg at what height? Y, no? So d cot theta. Directly I'm writing it. Do make observation. That of this will be mg. What is the R should be equal to L minus b cosecant theta. Take this much. So there's the interaction, or so there's a potential of the system. So simplify this. You'll get u as a function of theta, cot theta. Solve this, you bring in terms of u as a function of theta is asking. Then write the potential of system as a function of theta. You can further simplify this one. Knowing that potential of system will be maximum or minimum in equilibrium position, find the value of theta for equilibrium. Is asking now the equilibrium. So what shall I do for this? I'll differentiate this du by d theta, then d square u by d theta. I'll check for, is it a stable, unstable? If d square u by dt square, if d square u by dt square greater than 0, it will be minima. D square by dt square, if it is less than 0, it will be like a maximum will come. So with that, I'll check the maximum minima and find value of theta for equilibrium. Okay, proceed now. It's just math based, nothing to do. Only mathematics we have to work out here. No, this will be 2mgl plus mgd. I'm helping you with this. I solved it. I'm getting this one. So now you differentiate this. Du by d theta equal to 0. Differentiate this. Check for the theta. Anybody value of theta? Don't bother, sir. Pulley constraints, nothing. Just don't bother. It's a real mechanical system we have taken. That's all here. Earlier it was just in some mass based, no? A real mechanics system, what we consider. Anybody value of theta? Differentiate this and equate to 0. Check value of theta. Check again d square u by dt square, d theta square. Is it greater than or less than equals 0? Yes, nobody is there in class to very small basic differentiation I'm asking here, no? No answers? Oh. All of you, can you hear me? Ah, okay, fine, yeah. Ah, okay, fine. Arman, thank you, Arman. 60 degrees. Check d square u by dt square, d theta square, greater than or less than 0. D square u by d theta square, is it greater than 0? I think definitely substitute, differentiate twice, put theta equal to 60 degrees, it will come greater than. If it's greater than 0, what do you mean by that? Stable, unstable. It will be stable. Are you getting know? So if they give one blocks, wedge block, pulley block system, what you should do? You are going to take yourself reference u equals 0, then there what will happen? You have to analyze the system, get expression for potential energy, double differentiate it, check is it greater than or less than 0. Based on that, you can check is it stable, unstable. Or what is the other alternative method? Slightly, slightly displace the system. Slightly displace. So you don't displace horizontally. We are discussing about here vertical equilibrium. Slightly displace the system along y-axis. Check it now, how the restoring forces will act here. How the forces act. If the forces act opposite to displacement, stable. This is a mathematics. Another alternative method, disturb the system about equilibrium, and if any forces act opposite to displacement, stable. If the force act in the direction of displacement, unstable. There's a method. So they may end up asking you a physical system like this also. You have to be careful. I'm just alerting you. Now a small example I'll give it. At least you should able to analyze this. So here, let's take a what is this system? Stable or unstable? What is the nature of equilibrium? Anybody answer from here? You can expect in exams questions of this kind. You have to be very, very careful. Application is something very important. You slightly displace it. You slightly displace it. So when you displace this one, check it now. Any restoring forces like nothing, no? So what do you mean by the equilibrium, neutral equilibrium. You displace the position, again the net force will be zero. No destabilizing or restoring force will act on the system, and the potential energy remains constant. That's for the neutral equilibrium. So therefore, what is this? The system is in neutral equilibrium. In books, maximum we have only that mass-based questions. But this is if you go for Olympiad, no, you are being tested with all these questions. You have to be very careful. I'm telling this one. Okay, mains level.